Okay, so for a while I wanted to record something like this, where I'm just trying to program something, and recently this project, Scopane, I started it to work on something about file structure analysis, and I have recently noticed that I didn't have a PNG parser because I didn't write it. And so I thought this would give me the chance to record a small video wherein I go into the specification, the PNG specification, which I have right here on the screen. And I've written parsers like this before, so I have sort of a general idea of what I want to do. So you can check here, I have a JPEG parser. And I wanted to try writing the PNG parser from scratch, sort of, and checking the docs while I do that. So let's do a bit of split screen here, and I'm going to do, so it's going to be a PNG file, png.py, and this is probably what we're gonna do. Pretty much the same. Let me remove this a little bit. I don't think I'm gonna need regex here. Maybe I will. So let's just start like that and see what the PNG spec says. So the spec covers a lot of things, but we're interested here in the data stream structure, because this is what's going to give us the general idea for analyzing the file structure. I don't want to get into the details of the image or any other thing that's up here, right? Data stream structure is what gives us the layout for a PNG file. And what I've done with JPEG, let me see if I can bring it down here. So what I've done with JPEG, I have a segment class, right? So this would be a Chunk class, right? And the segment has basically everything. But JPEG is actually backwards on many things. I'm not a big fan of how JPEG files work. So what I did was, okay, I'm going to get a ton of bytes and I'm going to figure out everything after that. PNG is actually a lot cleaner in that sense. So a PNG file is comprised of a PNG signature and then a lot of chunks, right? And even the end of the PNG file is an IEND chunk, right? So it follows the specification that's written right here. So it's going to have a length of 0. It's going to say, hey, I'm an IEND chunk, and it's going to have a CRC for that, right? As this diagram shows. And there's no special casing, right? So that's fantastic. And I know, I always forget Python, sadlib, yes, CRC32 right there. So we have here CRC32. Beautiful. So we can actually have Python, so I import sadlib. So what am I gonna do with this? Pretty much the same that I do with the JPEG. I'm gonna get the raw bytes, which maybe I'll use them, and C type, not to be confused with C types. Start length, pretty much the same as we did with JPEG. provides, yes, C type, start, length, like that. And I'm gonna need a wrapper. Maybe not an str. I usually use them backwards from what Python officially recommends. So wrapper should have all the information for you to build an object, and str should be like a compact representation. I use them backwards because wrapper is what's printed into the console. So I'm gonna have a console here too. And let me actually have an environment here. I don't remember if I have IPython in the end. No, I don't, but doesn't really matter. So you have class A, right? And look like that. Return. This is wrapper for A. What happens with this? I use them backwards because if you're on the console, right? So you're gonna get that, and if I get one of these, right? If I have a list, I'm going to see wrapper all over the place, right? I usually work on the console, so I want the wrapper to be short. And if I need more details, then I'm gonna print that. That's how I usually work with the console. So that's part of the reason why I do this a bit backwards. So what we're gonna have here is this is going to be a chunk. Actually, I could do the better thing that I've done there on JPEG. That's good when you're subclassing. So you have call name, which is the big name here. Like it's going to be chunk for this one. But if I were to subclass this class chunk, I would get the class name nicely formatted. So I'm gonna get the C type. This is pretty much the same. I'm not using this syntax because it would print self that start. So just a little bit of and finally this. This way I can also comment them if I wanted to avoid this. So I'm not gonna do the printing actually because it's not really useful for the moment. And what I missed here is of parse, right? So let's do the parsing. What's the idea here? Pretty much the same as I did with JPEG. Give me a second, I have some music which is a bit too loud. What I did with JPEG parsing is I do have the chunk, and the chunk auto parses the bytes that it receives, but there's a function that's going to take care of most of the general idea. So it's going in JPEG I start with a list of segments, right? I'm probably gonna start here. Parse PNG data, and I'm gonna start with chunks. Okay, and yes, yeah, that sort of works. So, and I'm gonna return chunks like that. So So the idea is that in JPEG I try to parse a segment, a new segment, starting from the position. And then what I do is I get the length and I move the position counter a bit forward, right? I append this new segment to this list. So yeah, let's do it. Let's do pretty much the same. So chunk, it's going to be a new chunk, data equals onwards, and start equals false, and except, so I still don't know what kind of exception I could find. That's actually bad, but we're gonna fix it in a little bit. Exception Z I could do. So that's the generic exception. Shouldn't do that. Return chunks. And if that doesn't work, if that doesn't throw an error, I'm gonna append the chunk to the chunks list. So I had to do this with JPEGs because there are some variants of JPEG. Some camera manufacturers add additional information past the JPEG stream, and I didn't quite work what I would do in those cases. So I can do this, and actually this should also have a CRC32 value, which we're going to calculate in a little bit. So now class chunk object is going to parse itself, right? So what are we going to do? Pretty much the same we did here. Raw bytes like this, and actually when I parse before that, right, it always starts with 8, so usual position would be 8, and maybe I could have a special case chunk. It's not actually a chunk, it's a signature. Already with some differences. Right, this is what happens when I try to get it. Or I could just ignore the signature, but double check that. So I could do if data, the first 8 bytes of data is different from this binary structure, like that. No, it's from X. That's not X. Why is it in decimal there? Yeah, 78, 71, 13, 10, 26, 10. Is that what I want? Let's see over here. Why is that not the value? I like that a lot better. So literal value spec contain this, and actually I could link the spec over here. Paste the spec available online. Right. Okay. Let's move on. So if that's different, I'm gonna return chunks, like empty chunks. That's it. Oh, and I missed something here. I have to update the length. So pause plus equals chunk.length. Yes. Yep. I don't remember if I have to do +4. I think, well, let's read the spec. Let's get a bit with the memory. I think we could move this one up. We shouldn't be needing it anymore. So I was going a bit ahead of myself because I already know a bit of this. As the diagram shows here, a chunk, a PNG chunk, it's just a length, the chunk type, chunk data, and the CRC 32. So length, chunk type, and CRC are always 4 bytes long. Okay, so we have these 4 bytes for every single one, and as it says over here, length is 4 byte unsigned int, gives the number of bytes in the chunk's data field, right? How many bytes we have on this part, and the length counts only the data field, not the length itself, not the CRC. So actually we have to add 8 over here because we have to add 4 for the length and 4 more for the CRC. 0 is a valid length, right? And this also says something that encoders and decoders should treat the length as unsigned, right? So let me check if we have struct yet. I'm gonna add the parsing right over here. But there's also another mitigation. There was an attack a few years back. I don't remember the details, but it's usually weird to see very long chunks, right? Because even the data chunks, you can just split your data over multiple data chunks. PNG doesn't care, right? And even though it says 2 to the 31 minus 1, the limit is usually smaller, and you can even spot invalid or wrongly corrupted PNGs that have extremely long chunks. Anyway, we could do this over here. Length, which I could use self.length already. Struct.unpack, and does it say a little endian or b-endian? Let me search over here. Endian, little endian. Not a clue over there. So what can we do with this? I think it's little endian, so let's go with that. And this is 2, this, no, 1, 2, no, this one's, let's forget about this, so I'll put the struct. I always forget where it's I or H is 2 bytes. Okay. It's not X. Okay, so it's I. And I'm gonna assume that I'm giving it a valid chunk position. Okay, so and then I'm gonna try to find some errors somewhere, and this is going to give me the length. Okay, so what else do we need from here? chunk type is a sequence of 4 bytes that defines the type. Each byte of a chunk type is restricted to decimal values 65 through 90 and 97 through to 122. That's basically the 26 letters. So it can go AZ, AZ on uppercase and AZ lowercase. That's it. So it can have any text, but it cannot have numbers or any other things, right? I could write a regex to verify that. Usually we don't really care, but I would do this. I could do C type data, right, 4 through 8, and I could have a function or a list of valid C types. Let me see what's the best. I could have this. So if not valid C type for a C type, we could erase a value error, right? Invalid C type chunk type in file, and we have to write that function. And there's actually a very great way. Valid C type bytes. We can actually use a translation, translation table. So translation tables in Python are a very powerful thing whenever we want to check something. And what I'm actually gonna do is I'm gonna use this variant wherein it deletes all this. So why is that? That's it. Do you have all 26? Whoop. Did I get them all? Wait a second. Did I get which one? H. That's it. Yeah, right. What did I get wrong? Oh, D is twice. Why am I doing this? Because there's a bike going down the road. Beautiful. This is actually not art. My bad, that's CHR. And I'm gonna join them. This was a lot easier, but what did I miss here? Now I wanna see what I missed. Nothing. Anyway, just to be sure. And the other one said 97 to 122. 122 like that. So, why am I doing this? Translation tables in Python are used to change one character for another. And actually it's just a dictionary, right? So I could do str make trans a, any lowercase a, I'm going to change for an uppercase a, and if there's a b, I'm going to ignore it. Okay, so I get that dictionary, right? That's my translation table. I can just copy it over, and when I have that, I can do AAA, BAAA, like this, translate, and I can give it that translation too. And it's going to give me a new string wherein it replaced everything from this first argument by the corresponding character in this other argument. So I could actually do it backwards. I'm going to change any lowercase c to an uppercase a, and any lowercase a to a lowercase b, lowercase c, uppercase c, sorry about that. And I'm going to keep ignoring b's. So actually I want to do it like this. Okay, great. And the third argument, right, it's for ignoring. So my valid def valid, see, why is it not suggesting? Or here, sorry, no, it's C type function is going to check this. It's going to get a C type. And it's going to return if C type translate valid C type bytes is equals to an empty string. And actually, I have a little problem here. Yeah, I have to work with bytes. And does it take from 2? I don't have the... Ouch. This is a bit of a foot gun. I have bytes over here, so that's a problem. I don't want to write a regex for this. I could write a regex for it though. I want you to use make trans, but this one doesn't work like that, right? No, it only takes 2, so only for translations. Okay. Let's do it alright. It's rx valid c type, compile. So AZ, and I want to sub it for nothing. Rx.sub. Repl. That and C type. Copy this over here. C type. So I get, that should be true, so I get 6 false. txt, and this is true. Okay, seems to be working. Nice. I really wanted to use matrix though, so my bad there. Chunk data, whatever data is there, right? There's a few other rules here. Like if it's all in uppercase, it's a mandatory field, not mandatory, but a standard field, right? That every encoder and decoder should know what to do with it. That's why we have chunk naming conventions a bit down the document. And if the first and the last letter are lowercase, then it's just an optional field and your encoder or decoder can ignore it. It should keep it, right? Because maybe some other programmer knows what to do with it. But that should be about it. and then we have to get the data, which is exclusively the length that we've already gotten, right? And it's after not itself, not the chunk type, not the CRC. So self.data raw bytes should actually be, actually I want to keep all the raw bytes, but data itself, maybe I should do it like this. I'm not gonna change raw bytes. Sorry. So length for the length, for the type. So plus 12 like this. But I'm gonna do data. Self.data. It's actually gonna be 8 up to 8 plus self. So this may be a bit weird, and yes, data could obviously be just ignored, or I could keep just data, but this may help a bit down the road if I want to add some parsing of data itself from different or from standard chunks at least. I just want to get the general structure of the file now. I don't care about parsing the data at the moment, but that could be something of interest later on. I don't know, maybe I could have a IDAT chunk subclass that takes care of reading IDATs. So there's the data. Oh, the CRC. That's what I was missing. And I could also add another control flag here. Maybe do flag out of the CRC check equals true. And this could be self.flag CRC check flag CRC check. Yep. So over here, CRC calculations can be demanding, not very much in Python, sadly. CRC implementation is decent, it's more than decent, it's really good. But maybe we want to avoid that, right? So what I would do is, there's the CRC there, so self.crc 32 is equal to data. The last 4 bytes of data should be the CRC 32. And if self.flag CRC check, I should check with setlib, like CRC calc setlib.crc32, and it takes a readable buffer, right? And I could have a starting value for the checksum. We don't need it here, so just passing the data. And it says it takes the chunk field type and the chunk data files. Fields, not files. So did I say file both times? Field. So I take everything but the chunk length and the chunk CRC, right? And if CRC calc, why are you not auto-completing, is different than self.crc 32, I'm gonna raise a value and I'm gonna say invalid CRC 32 for chunk. And I believe that's about it. Did I set the length? Yes. Okay, so is this all that I want? There's some ordering, right? So if I have an header and I can only have one header, I need to have it first, then I'm going to have a PLTE, right? I cannot have a PLTE after an IDAT, and I can only have one IAND, I can only have one CHRM, I can only have one gamma, one ICCP, one SBIT, right? And well, all this I have to find in specific locations. I'm not gonna go into those details yet. Let's try and see if this works. So I'm gonna save this and go over here and let me try something. There's actually like this. Let me see if I have it right. No, I don't. It's loading the one from the. Why is it loading that one? I don't really want to pip install every single time, but whatever. Oh, because the IPython's not local. Is that it? Okay, so scope.png. Beautiful. Parse PNG. Okay, so let's keep that at hand. So read open empty / gimp. No, because it's test files, empty. Yeah, that's it. RB ZF. There you go. I'm gonna read all that. That's just an image made with the GIMP. So scope PNG parse PNG data. And yay. So let's debug what's wrong here. What did I do wrong? Hello. I could copy this so. Yeah, should go this campaign. PNG data, same. I love print debugging. That's actually so. Yeah, why? Why is that? Did I write that wrong? Yes, I wrote it very wrong. Why? Oh, I copied it wrong from here? Yes, I did. It was 137, not 127. Beautiful. Yep, so let's fix this. Now let's fix that over here as well. Okay, this is much better. What's the problem here? Unsupported operand type. Let me turn this off. That's the problem with that. I'm not getting the exception as I wanted. Alright. Because this is actually on chunks. I'm missing a comma there. Why? Because actually unpack, if I were to take this like this, sorry about that, it returns the top of things, right? And if I don't parse that correctly, right, if I don't unpack that, right, I should do either this, assuming that it's going to return something, or I can do unpacking like that. So this is actually better to uninstall skipping, and yes, pip install self Python import skipping with same as before, and parse. Okay, that's actually better, or better error than I was expecting. So I'm gonna do this so that I can see the error. Or I could just turn off the flag. What was the flags receiving? False. Let me see if it works now. And it was not big endian. It was actually real, because let me see this. Import struct dot pack. It's actually this. And let me see data 8 through 12. But it's actually, yeah. So it's big endian. So I figured the endianness could be a problem, not the little endian, like big endian. And that actually makes sense because PNG is portable network graphics. And oh, we have to uninstall. And usually network stuff, same as Motorola and ARM and everything that's not Intel, is usually big endian. So import skipping, oh, let it open, let's read data. And now we have the problem with the parse, with chunk. Oh, because I'm probably just doing the same. Right, because this returns a number. That's the problem. But let's try it like this actually. Whoa, almost. And because I turned off this, I would probably just survive that one. With this horrible thing. Right, so I could do why the second chunk? Sorry, let's do it like that. Yeah. Yeah, my problem is that I did really wrong over here. So is that correct? Hmm, 16. Why 16? Let me see something. Am I missing something else? Oh, my bad. It's +12. That's okay. Because then I have the length. So this check should be fine. Parse that's +12. And that's it. Am I not getting the type? I never set the C type. And also, let me get this. I'm gonna print. That's a print. And this is gonna be debug. Of course, it's gonna be debug. CRC calc and self CRC 32. Install script. Yes, and I'm gonna pass over here the flag. I'm gonna pass it as false, so I can check. Wait a second. If I just uninstall it from the, I can import it. And run it local. Yeah, that would have been much better. So with open like this. Beautiful. I could probably decode this like this. Oh. Sorry. I didn't get it. Oh well. Well, it's parsing correctly. And it's usually better to not reload and just close the session and open a new one. Not like that. Yes, why? Because what I've read is not what I. So import struct. I'm gonna have to either decode this or encode the other. It's pretty much the same. That's wrong. That's not the value. Check this back. The number. What? Am I getting the wrong values? I'm so getting the wrong values here. Because I'm passing the whole file. So actually I don't know where it is. I mean, I do know where it is, but I'm passing the whole file, right, from the position where I'm in up to the end of the file. That's why it's giving me the wrong value here. So actually, where do I want to calculate this? I want to calculate this from position plus 8, right, because the CRC does not include, oh no, sorry. So from plus 4, because it takes the chunk type and the data field, not the length field, and not the CRC. So it's going to be I don't have pause there, so I'm from 4 up to 4, actually 8 plus self dot length, like this. So let's give it a try. This is what happens when you don't check absolutely everything. Not quite the same. Wait. It could be the same. And nope. Not the same. What am I doing wrong now? You don't have to include the what am I doing wrong now? What I calculated was that what I read was something else. This another no. From 4, that includes the data chunk, yes. Let me debug this too. So data, all that. What am I going to do? So, okay, that's fine. Okay. Am I missing anything from the docs? I really have to check this. Back in the day I solved this. So GitHub, InfoLab, yep, file validators. So this is a really old project. Oh, we had that there. So what did we do? what did we do? Okay. Chunk data. So it leaves your C32. They are the same. So what's the problem here? So what does this all do? Where did I find it? Up here? No. L instead of I. Really? Struct, not strict. You're kidding me. It's not your. This is going to give me a headache. Why I and L are the same? Probably let's do with L. I think I may be platform dependent. So did I? That's PNG. Yep. Oh no. Did I use UL or SL? Signed. Should interpret it as signed. Did I copy it correctly? Yeah, even then that's a problem because this thing. Let me try something here. So that's my chunk. Let me see. Let's chunk data. And so yeah, that's the following chunk, so we're fine there. I have my chunk data and my CRC32. Now this is my problem. That's it, found it. Probably no debugging, no further debugging needed. Scoping with now. Did I save that? No. Actually, like this. That's for trying to do things faster than I should. So I'm not entirely sure about the CRC yet. It will fail because I still didn't convert things. That's looking nicer. Struct, not a struct. So back, where's back? And that's it. Now it's fine. So that was on me for being an autopilot. You can go out and so CRC calc. It's actually struct pack. Now it should all be fine. I'm calculating the right places. And beautiful. Oh, one last thing I wanted to do. I wanted to decode that as UTF-8. Because it's going to look a lot nicer, so just because of that. Beautiful. You're right there. That's 0, 1, 2, 3, 4, 5. Okay. Beautiful. So this image was created with the GIMP, and I wanted to check that iText right there. I could also check the time here, which is a timestamp. Like I said, potentially I could work a few of these more details, but here's the kicker. I was working on this because a friend of mine was working with Stable Diffusion. So I asked him, image1.png. So I asked him a few files, and yes. And the fun part about this, oh, sorry, that was bad. The fun part was that we found that at least I didn't ask him for details about what he was using, but his Stable Diffusion, or I don't know if he used another model, inserts a text field, right, which has a common. I don't see it here with properties. Maybe Xftool parses it, but I just was having fun with file structure. Okay, and for example, the file structure here tells me something about encoder, and you can notice, let's call this GIMP data, and let's keep the other as data. You can notice that GIMP are in the same file. So it was GIMP. Yeah. GIMP, all the IDAT fields are 8 kilobytes, and this other are 64 kilobytes. That's a difference in the encoder. All right, that's interesting from the file structure analysis point of view. And you can also see that GIMP includes ICCP, BKGD, fizz, time, text, right? Text is usually a comment, right? And you can read that with EXIF tools, most probably. I'm pretty sure you can read that with EXIF tool. But on the GIMP, right, this comment was field 5, I believe, yes, that data, right? It says comment in accordance to PNG's specification, and say, hey, this was created with the GIMP. Now, if I just check this other data, I can see that the text is the second one, and if I read this, I can see that it's actually the prompt and the parameters and the configuration that was given to the specific model, AI model. So I can see that my friend said, okay, create an image, which the prompt read a serene sunset at Mar del Plata beach, golden hour, blah, blah, blah. And you can keep, if I actually print this, sorry, and I could actually also decode it. So most probably UDF8, please. All right. So there's a /00 there. And I can see the negative prompt, the steps, the sampler, the schedule typo, a lot of different things, a lot of different parameters for the AI model. So this is what I was after. That's why I didn't need pretty much any other thing other than just getting the structure and well, just a simple parser. So this is usually how I work this kind of stuff. I don't really have a lot more to say about this other than that's also why I wanted the data field as a separate data, right? If I tried raw bytes, right, which we also have here, I would be getting the decoder errors, right? Because I had to be trying to parse things that is just not text. So that's it for this PNG parser. That's about all I have to say about this. I hope it was understandable. And well, what could be steps forward is notice that, well, the CRC check was already implemented in Python. Didn't have to implement it on our own. It's very good. We can just keep using it. I could work a bit more on chunk ordering, right? Oh, and just a little something. If I were to time this parse. Now let me do Scopan, yeah. Let's say that for whatever reason I want to time this. About the CRC checking, right? Remember that. How much is this line of data? Okay, and so this is parsing at about 267 megabytes a second. That's a lot from memory, right? So I'm usually gonna be the bottleneck's gonna be on the disk, not anywhere else. But remember that we had this variant where we would avoid checking the CRC file. So it gives the same result, right? PNG parse. Not the same results. Why not? Really not the same? Oh, because I did not implement the EQ magic. But we can see it with our own eyes, right? The IND is at the same location. It's the same. So we're using the same. This one goes at that speed, at about 5 point something milliseconds. If I skip the CRC checking, it's gonna go a bit faster, right? Not fantastically faster, but it's 15% faster. What does that mean? Well, for 64, it's going at about 300 megabytes a second. If you know for a fact that your PNGs are well formed, right, and you don't suspect any kind of corruption, you can avoid that, right? It's good that the format has that, but that's why I also included, not just for debugging purposes, obviously. It was there for debugging, right? But I could also play with this to gain a little bit more of speed. Even then, probably the worst offender here is that I'm doing lots of copies, right? Whenever I do this, this is a data copy. This is a data copy. This is the data copy. This is the data copy. So I could potentially minimize that a little bit. But it's not really something that worries me now. I don't have tons of gigabytes of PNG files to process, and even if I did, there are some venues that I could pursue to optimize this. This is about everything I wanted to do today, and hope you find it interesting.